Hello friends, in continuation with previous video, we would like to calculate the effective pressure for different conditions of the soil due to capillary effect. When the capillary water shoots up in the ground, how does it affect the effective pressure? So today we will see the effective pressure distribution. Let's take one example. Such examples are often asked in GATE and other public service commission examinations. So it is the ground situation. I will show you with the help of a figure. This is the ground level, and this is 3 meter, and here is the groundwater table, and up to 1 meter, due to capillary effect, the ground becomes saturated. Due to capillary effect. So this is 1 meter. Naturally, this is going to be 2 meter. This is dry or moist condition, and gamma T is given to you as 16 kilonewton per meter cube. And the gamma saturated here is 18 kilonewton per meter cube, and this extends up to 8 meter. So there is a sand, completely sandy deposit. There is sand, there is also sand. So for this condition, the calculate the effective pressure at say this is AA, this is BB, the dotted line, this is CC, and this is DD. So at 0 meter, then you want to calculate at 2 meter, then at 3 meter, and lastly 10 meters. So now if you see the solution of this problem, the solution is going to be as it is clear over here, that you need to calculate the total stress positive or total pressure, that is sigma. Then you need to calculate the pore water pressure, which is called U, and the difference of the two is the effective pressure. So the effective pressure sigma prime equal to sigma minus U. So in a tabular form, if you calculate, it would be easy to calculate. So depth Z in meter. What are the depth? It is at 0 meter. Then you are going at 2 meter, then at 3 meter, and then at 8 meter. Then what is the value of gamma unit weight in kilonewton per cubic meter? That's known, that's given over here, 0 at 0 to 2 meter, it is going to be 16. At 3 meter, it is going to be fully saturated because of the capillary action, and it becomes 18. And up to 8 meter, it is going to be 18. Now, you can calculate the total pressure sigma equal to gamma into Z. This will be in kilopascal. So calculate pore water pressure and calculate the effective pressure. This is how you can calculate it. At 0 meter, there is no pressure at all. There is no surcharge. So it is going to be 0. So there is no column of any soil or anything. So at 0, 0 or at A level, this is going to be at A. So level at A. Naturally, there is no column of water above that, so it is 0. So the difference is going to be 0. This will be gamma W multiplied by ZW. Now, when you go to 2 meter, you have the dry unit weight, and that is 16. So 16 into Z will be 2, that is 32 kilopascal. And the pore water pressure can be explained over here. You can see here that this is CC, this is BB, and this is A. Now from this level 3 meter to up to 2 meter level, you have capillary rise. So due to capillary rise, the pore water pressure here will be like this. It will be negative due to surface tension, and this becomes, if this the height is SC, U will be here SC into unit weight of water, and it will be negative because it is negative pressure. And here, the moment you come to the groundwater table, the pressure becomes 0, and then the pressure becomes positive. So negative pressure in this zone, BB to CB. So between this and this, there is the negative pressure distribution. So at level BB, the pore water pressure is going to be negative due to capillary action. It is the capillary rise. The groundwater shoots up and makes the soil saturated up to 1 meter. So at 2 meter, what is the column of water? There is at 2 meter, the pore water pressure here at this location is going to be different. It is going to be minus SC is 1 meter, as I have given you that this is 2 meter. So this is 2 meter, this is 3 meter. So naturally this is 1 meter. So SC becomes 1. And gamma W can be taken here in this problem. Take the unit weight of water equal to 10 kilonewton per meter cube. So this is the pressure. So now sigma minus U, if you do it, it becomes 32 minus of minus 10. This is minus 10. So this becomes equal to 42 kilopascal. So at 2 meter, the effective pressure is going to be 42 kilopascal, and this is at level BB, the pore water pressure. And at CC, that is at 3 meter. Now, what is the total pressure? Total pressure is 16 multiplied by 2, that is 32 plus. This becomes now 18 because it is fully saturated with capillary water. So plus 18 multiplied by 1. So 32 plus 18, it becomes 50. 50. And what is the pore water at CC? It is 0. There is no column of water. It is the negative pressure becomes 0 at ground water. Due to surface tension, it is negative here, and maximum is going to be at the top, and at the ground level it becomes 0. So pore water pressure here will be 0. There is no column of water, static water. So therefore, the effective pressure becomes 50 minus 0, that is 50. So this is at CC. And now come to the point at DD. So at DD, the pore water pressure can be computed. At DD, at this level, what is the total pressure? It is 50 already up to cc plus. Now the remaining is 5 meter, right? So it is going to be 8 minus 3, that is 5 meter. So 5 multiplied by 18, it becomes 90. So 140 kilopascal. Right? And what is the pore water pressure? When you put a piezometric tube, this and here at this level, the water will rise in the piezometric tube, in the piezometer, up to this level. So there are 5 meter of, there is 5 meter. So water in the standpipe or in the piezometer goes up by 5 meter, and this is going to be positive. So this becomes 5 multiplied by 10 is 50 kilopascal. So U in kilopascal, and the effective pressure will be also in kilopascal. So therefore, 140 minus 50 is going to be 90 kilopascal. This will be at DD. So friends, you can see how the problems can be solved. Now, if you want to show the pressure distribution, once you calculate in a tabular form, so in a table, you have shown the complete calculation of total pressure, pore water pressure, and effective pressure. And therefore, it is very easy to plot it also. So if you want to plot it, naturally, you can do it very well. So, having got this table now, the complete solution is with me. If I want to see, there is zero pressure at A. So the pressure is zero here. But the moment you come 2 meter down, your total pressure is going to be 32. So at this level, it is 32 kilopascal. When you come to this level of cc, then the pressure increases from 32 to 50. So it is going to be 50 kilopascal. And when you come down to 8 meter, what is the pressure at DD? It is 140. So this shows you variation of total pressure sigma in kilopascal. Now, what is the variation of pore water pressure? This is the reference line. The pore water pressure here is 0 at the top, and 2 meter down the line, it is minus 10. So it is going to be here negative pressure, and negative pressure is going to be, so pore water pressure becomes minus 10 here. So minus is going to be here. So 0 to minus 1 minus 10, the pore water pressure. And then it becomes at cc, that is at this level, it becomes now 0. So the pore water pressure cannot be shown like this, because it is 0 here. And in this zone, the pore water pressure I have already shown you. Here it is minus 10 and it becomes 0. So it should be shown like this. 0, minus 10 here, and then it becomes 0 at CC level. And then uh, uh, it becomes 50. So from this, it becomes 50 here. So this becomes the distribution of pore water pressure. Naturally, the effective pressure you can also plot. The effective pressure is shown here. It is 0 and then it becomes 42 here. So 32 minus plus. So here the effective pressure becomes 42. And then at CC it becomes 50. So here it becomes 50. And then it becomes 90. So here it becomes 90. So this is the variation of effective pressure. So this is due to the effective pressure distribution and due to capillary rise. So if there is capillary rise, how the distribution is going to take place has been explained in this particular problem, and both in GATE examination and in public service examination you will find such questions of this nature. So I hope I have explained this part very well. Friends, in the next problem now, let us see the effect of surcharge. Q. Let's say I take a problem. There is the ground surface and the soil mass is going to be fully saturated. So if it is fully saturated and surcharge is the gamma sat is given to you as 18 kilonewton per cubic meter up to 3 meter. Say it is sand and then it is clay for the remaining 8 meter and gamma saturated is 20 kilonewton per cubic meter. The water table, groundwater table, is touching the GL, ground surface or ground level. So this is the problem. And the value of Q, surcharge, is 30 kilopascal. So how will you solve this problem? Now, because you are going to apply the surcharge suddenly due to surcharge, at ground level, that is at 0 meter, 0 meter, what is the value of total pressure? So at 0 meter, the value of sigma, the total pressure, is going to be 30 kilopascal. So the total pressure at 0, 0 is this. And here, the pore water pressure, because you are going to apply this surcharge suddenly, surcharge 30 kPa will be transferred to the pore water because you are applying this surcharge suddenly. So immediately the pore water pressure will shoot up. The pore water pressure is going to be 30 kilopascal. And therefore, the effective pressure is going to be difference of the two, 30 minus 30 equal to 0. Now come to the level of 3 meter. At 3 meter, your total pressure is 30 plus now, surcharge plus 18 multiplied by 3, that is 54. So it becomes 84 kilopascal. And the pore water pressure is 30 plus. Now, the water table here at 3 meter, if gamma W is given over here as 10 kilonewton per cubic meter. So taking gamma W equal to 10 kilonewton per cubic meter at 3 meter, the water table will show 10 into 3, so it becomes 60. So the effective pressure becomes 24. And at 8 meter level, when you go down, there is going to be 84 plus. From 3 to 8, that is 5 into 20, it becomes 184. And the pore water pressure is going to be 30 plus. Now it is 10 into 8. So it becomes 110. So effective pressure is going to be 74. So if you want to plot it at pore water pressure, effective stress is going to be 0 here. Then as you go down, it becomes at 3 meter, it becomes 24, and the at this it becomes 74. So 24, and this becomes 74 kilopascal. And if you want to plot this value of sigma, this becomes shear. Total pressure due to surcharge, it is 30. So it is going to be 30 at the top, and then at 3 meter it is going to be 54, and it becomes 54 plus 30, total it becomes 84, and it becomes 154 plus 30, so it becomes 184. So this is the variation of total pressure over the entire length of this. This is due to surcharge, and this is the total pressure. And this is how you can calculate the effective pressure. Also, the pore water pressure, you can show the pore water pressure here. If you want to show the pore water pressure, it is at Z equal to 0, it is 30. So it is going to be pore water pressure U is 30 kilopascal at the top. So throughout, due to surcharge, and then it becomes at 3 meter another 30. So it becomes 30 plus 30, 60, and 30 plus 80, it becomes 110. So there is the variation of pore water pressure. So pore water pressure variation can be shown, effective stress variation, total stress variation can be shown. This is how you can attempt this particular problem. So Artesian effect, in the next video I will take it, and I will explain to you how, due to Artesian pressure, there is change in effective stress, which is very, very important. So in the next video, I will do that. I hope both capillary and surcharge is going to be quite clear. One point more over here. Here, I had taken the problem where it was groundwater table was here at the ground level itself. But if the groundwater table is below this, then you can't, there will not be any shooting up because it is dry. So the pore water pressure will not shoot up. So friends, certain things must be kept in mind, and accordingly you should try to solve the problems. These are some of the important tips that I wanted to give it to you. I hope that the points are well taken. So in the next video we will do further. Thank you.